What's up guys, here I am with another CODEWARS video, and this problem, it wasn't difficult, but I was a lot of time thinking about it until I got the answer. It is very simple. So the problem is just that, hey, they give us an n and we have to calculate an m and a k that m to the power of k is the same as n. Apparently this is a perfect power because m has to be bigger than 1 and k has to be bigger than 1, and yeah, that's it. So how did I do this? In order to understand how did I do this, I'm going to do a very simple draw. Well, it's not a draw. So yeah, for example, let's say that we have the number 9. If we have the number 9, it's very simple because it's the same as 3 to the power of 2. This is m and this is k. But if we have, for example, 10, this is equal to 5 by 2. So we cannot do this. This is not a perfect power because the result has to be m to the power of k. And here we have 5 to the 1 and 2 to the 1, and no, you just need to have here one number to the power of another number. This has to be the result of that. So for example, 25, or for example, I don't know, 27. 27 is the same as 3 to the power of 3. And I realized that all those numbers are have as an m a prime number. Like for example, if we try to do 8, this is the same as 2 to the 3. But if we try to do 16, this is the same as 4 to the power of 2. But this is exactly the same as 2 to the power of 2. So at the end, you have a prime number as an m. But in the problem, it said that if you give this answer, it's totally okay. It's just that it's apparently always has a prime number as m. So yeah, let's check my solution. And it was very simple. What I did is, okay, I have to check the numbers. And look, I could have just checked the prime numbers, but I don't want to put I could put here a function saying, hey, is the number that I'm going to check a prime? But I really don't want to do that. So basically what I'm doing is going from 2 to the square root of the number, because if we receive, for example, 9, it doesn't have sense to check 8, for example. Let's check if 8 to the power of 2 is equal to 9. That doesn't have sense. We can stop just until 3. Whenever we reach 3, we have to stop because 4 to the power of 2, then this number is always going to be bigger than 9. So that's why I'm using the square root of n. So yeah, we go from 2 to the square root, and then I check if the number that we are going to try is divisible, I don't know if that's right said, by n. What this means is, for example, if I divide 9 by 2, 2 is not a divisor, I don't know how to say, of 9. Why? Because the result is not a natural number, it's not an integer number, it's I don't know, it's 4.5. I want to have as a result an integer number. Sorry that my English is not very good, but these kind of things are very complex and I don't know all the vocabulary on English to explain these things, so sorry about that. But yeah, I'm just checking that the result of the division between the n and the number that we are going to check now is an integer. And to check that, I just divide it, and here, for example, it could be 4.5 minus the division truncated, and if the result is an integer, this is going to return 0. But if it's not an integer, this is not going to return 0. This subtraction is not going to be 0. Then I check the power, and I call this function, which is check, which I give the number and the number that we are going to check. So yeah, the check function, what it does is, for example, let's say that n is 4 and that I is 2 because it's the first number. So what I do is, okay, power of 1, here I have a 2, so 2 to the power of 1 is 2, and I do, okay, while this accumulator 2 is less or equal than 4, do this loop. I check if the result stored in the accumulator is equal to n, then this means that we found the power and that this number is okay. So if not, I increase the power and increase the accumulator. So for example, in the accumulator, I increase the power, and here I have a 2, and the accumulator stores now to the power of 2, which is 4. In the next iteration, it checks this, okay, this condition is fulfilled, and then it checks this, and this condition is also fulfilled. So we return the power, which is 2, and that's why here, when we call the check function, we store the result in this variable, and if you check this, if we go out of this loop, it means that that we didn't find any power and that we are returning none. So if we didn't find any power, we don't have to return anything. But if we found anything, like if the function returns something that is not none, then we just return that, and that's the result. So yeah, that was my solution. I hope you understood it. I know that like my vocabulary with these kind of things is not perfect. I have to improve it, but I'm working on that. And yeah, this is very useful, and if you like the video, just give it a like, subscribe, and share it. Don't forget to go and check my website, in which I talk about trading and cryptocurrencies and all that stuff for a very cheap price.
Damn, Sosa. You going crazy.
Rest in peace, Big Pop. Quédate tranquilo, 666. Estoy bajando todo, lo siento. Te quedas en nada. Rest in peace, Big Pop.